On the islands of the Philippines, nature has always been both a friend and a fierce opponent. While lush greenery and tropical beauty define the landscape, this same environment faces a constant battle: landslides, coastal erosion, and the encroaching force of the ocean. In a world where climate change continues to accelerate, this battle has only become more intense. But in the heart of these struggles, something remarkable is happening. The Philippines is turning a humble fruit, one that grows in abundance across its islands, into a powerful tool for protecting its land and its people. This is the story of how the country is using coconut waste, yes, waste, to fight erosion in a sustainable, low-cost, and surprisingly effective way. The Philippines is one of the top coconut producers in the world, with more than 300 million coconut trees spread across its 7,000-plus islands. The country produces over 15 billion coconuts every year. Coconut farming is a cornerstone of the rural economy, providing income to millions of Filipino families, especially in coastal and agricultural regions. The industry supports a vast network of farmers, harvesters, processors, and traders. However, this massive production also generates enormous volumes of agricultural waste. The most commonly discarded part is the tough, fibrous outer husk, which typically ends up burned in open fields or dumped in landfills, contributing to pollution and carbon emissions. Despite its potential, this waste has long been underutilized. At the same time, the country faces worsening environmental threats. With its location in the Pacific Ring of Fire and the typhoon belt, the Philippines is hit by an average of 20 typhoons per year. Combined with deforestation and rapid urbanization, this leads to frequent landslides, coastal erosion, and flash floods that displace communities and destroy livelihoods. Engineering fixes like concrete walls or dikes are costly, hard to maintain, and often inaccessible to remote regions. The need for a sustainable, low-cost, and scalable solution has never been more urgent, and the answer may lie in the coconut itself. The outer layer of the coconut, called the husk, is usually considered a byproduct, but hidden within that fibrous shell is a material called coir, a tough, durable fiber that's resistant to salt water and decay. Locals and scientists realized that these fibers could be woven together to form nets, mats, and rolls that could help hold soil in place and protect vulnerable coastlines. These creations are known as cocoa nets, cocoa mats, and cocoa logs, and they're quietly transforming how the Philippines fights erosion. Cocoa nets are large mats made by weaving coconut fibers into mesh-like patterns. These nets are laid over sloped areas, like hillsides or road embankments, to prevent soil from washing away during rains. They act like a natural carpet, holding the ground together while allowing vegetation to grow through them. Cocoa logs are even more impressive. These are long, dense rolls made from packed coconut husks wrapped in coir netting. They're often placed along riverbanks, coastlines, or areas where water flow can cause serious erosion. Think of them as biodegradable speed bumps for water, slowing down the force of runoff, trapping sediment, and encouraging plant growth. Over time, as the logs break down naturally, vegetation takes over, creating a self-sustaining barrier that's completely integrated with the environment. What makes these coconut-based methods so attractive isn't just their effectiveness. It's the way they address multiple problems simultaneously, creating a win-win solution for both people and the planet. First, they provide a smart and sustainable way to manage agricultural waste. Coconut husks, which are typically discarded or burned after harvesting, are now being repurposed into erosion control tools, such as coir logs, cocoa nets, and mats. This reduces the environmental burden of waste disposal while transforming a byproduct into a valuable resource. Second, these materials are fully biodegradable. Unlike conventional erosion control methods made from plastic or reinforced concrete, coir products break down naturally over time. They don't leave behind microplastics or other pollutants, and their decomposition process even enriches the soil, making them a far more eco-friendly option. Third, they are cost-effective and easy to produce using local labor and resources. This is particularly important in rural areas, where budgets are limited and access to industrial infrastructure is scarce. Villagers can weave the nets and shape the coir logs using simple tools, which not only provides jobs, but also empowers communities to protect their own environment. Moreover, these coconut-based structures do more than just hold soil in place. They support long-term ecological restoration. As they stabilize the ground, they create ideal conditions for plants to grow. Native grasses, shrubs, and trees can take root within the core fibers, gradually reclaiming barren or damaged areas. Over time, this leads to more resilient landscapes that can better withstand future storms and floods. In this way, the humble coconut goes beyond erosion control. It becomes a catalyst for regeneration, turning waste into opportunity and environmental damage into a chance for renewal. This isn't just a theory, it's already working. In the mountainous province of Benguet in northern Philippines, landslides used to be a constant threat during the rainy season. Roads would collapse, farms would wash away, and communities were left stranded. Now, thanks to cocoa nets placed along the hillsides, the soil holds firm. Grass and local plants grow through the nets, forming a dense cover that keeps everything in place. On the island of Mindoro, coconut logs are being used to protect riverside farms. Farmers who once lost their land to rising waters are now seeing their soil stay intact and their crops flourish. Even in coastal areas like Tacloban, where Typhoon Haiyan caused catastrophic flooding in 2013, cocoa logs are helping rebuild natural defenses. The logs slow down wave action and reduce erosion along the shoreline, giving mangroves and native plants a chance to grow back. The Philippines isn't the only country experimenting with coconut-based erosion control. Other coconut-producing nations, like India, Sri Lanka, Indonesia, and parts of Africa, are starting to take notice. But what makes the Philippines a standout example is the way communities have embraced the idea from the ground up. Local governments, nonprofits, and village cooperatives are working together to produce and install cocoa nets and logs using traditional weaving techniques. In some places, women's groups have formed micro-businesses around core production, earning income while helping protect their own communities from disaster. The result is a rare blend of tradition, innovation, and sustainability. Of course, coconut-based erosion control isn't a silver bullet. In areas with extremely heavy rainfall or fast-moving water, cocoa logs may need to be combined with stronger infrastructure. And without proper training, installation can be inconsistent. But the concept itself is powerful. As climate change continues to intensify storms and raise sea levels, the need for low-cost, scalable, and environmentally friendly solutions will only grow. And that's where the humble coconut shines. What was once considered waste has become one of the Philippines' best defenses against nature's fury. In a world where high-tech solutions often steal the spotlight, it's easy to overlook the simple brilliance of nature-based approaches. The Philippines has shown that by working with the land, and not against it, we can find resilience in the most unexpected places. All it takes is a bit of fiber, a lot of community effort, and the age-old wisdom of using what you already have.